Let's talk about acid rain. Somebody asked me the other day about what acid rain is, and then another person said to me, then, acid rain doesn't exist. So there's a lot of misconception on this issue, so let me clear some things up for you. So, on the umbrella topic of acid rain, let's first talk about carbonic acid, because there's several different acids that get formed. Let me first say one thing. All rain is going to be slightly acidic. All rain is going to be acidic. Question is whether it's very, very mild, extremely mild acidity, or potent acidity. So it's a range, and if you're familiar with high school chemistry, think back to molarity and concentration of a molecule rather than just the presence of a molecule. Okay, so but this is not a lesson on molarity, but let's just talk about how rain becomes acidic. Okay, first step. The first one we're going to talk about is carbonic acid. So this is almost entirely natural. And what happens is that CO2 in the atmosphere combines with H2O sub G, the gaseous form of water vapor in the atmosphere, and becomes H2CO3, carbonic acid. This is naturally occurring in the atmosphere, but it's increasing. As CO2 goes up, then the reaction goes up, right? So you remember from chemistry, as you add a reagent, then the reaction increases, right? The product increases. H2CO3 is going to increase as we add CO2, obviously. So this is your water vapor. Now remember, water vapor itself is a greenhouse gas, and then that's going to go into a positive feedback loop, but we'll talk about that later. The second one we're going to talk about is nitric acid, okay? We're talking mostly about the transportation sector and internal combustion engines when we talk about nitric acid. Now, it does come from coal, and we'll get to that in a second, or burning with fossil fuels. You really burn anything with atmospheric air under pressure, you're going to get nitric acid. Remember, like 78% of this fluid that we're swimming around in here is nitrogen. So, of course, every time we suck a whole bunch of nitrogen into an internal combustion process, regardless of whether we're making electricity or we're driving to work, then some nitric acid is going to result. But here's how it goes down. It is not a primary pollutant. Let me say that. Nitric acid is not a primary pollutant. Here's what happens. This is my car. And what's going to go in is oxygen and nitrogen from the air. Now I'm going to get CO2 produced, but that's not what we're talking about here. That's over there at carbonic acid. Okay? NOx, NOxes. So the X is there as a variable, just like in algebra, because you can get NO, you can get NO2. Primarily what we're talking about is nitrogen dioxide, NO2. Okay? NO2, we're going to call NOxes here, is produced, and that's the primary pollutant, because that's the initial pollution is the NOxes. That's going to combine with water vapor in the atmosphere and create nitric acid, HNO3. Okay? So the last one we're going to look at is sulfuric acid. Sulfuric acid is mostly, when we talk about sulfuric acid being created in the atmosphere, mostly what we're talking about is the coal burning process, because coal has sulfur in it. Now, there are other things that can create it, okay? And it can be there can be natural sources of sulfur dioxide in the atmosphere, like volcanoes, for instance. But primarily on this test, you need to know the anthropogenic, meaning man-made, sources of SOxes, and here's why. We're going to take Thomas the Train here. Thomas the Train is full of sulfur containing coal containing sulfur. Help if I can talk and read at the same time. Anyway, so Thomas the Train is going to bring the sulfur containing coal to the power plant. We're also going to suck in nitrogen and oxygen because we are burning it, right? Then we're going to have SOxes created. So that's primarily sulfur dioxide. But again, the X is there as a variable because it can be several sulfur oxygen compounds that are being created. Primarily what's being discussed here is sulfur dioxide, SO2. Okay? That's the primary pollutant. That's the reason it's in a different color. That's going to combine with water in the atmosphere to make H2SO4, sulfuric acid. Now, in this diagram, because we're sucking in nitrogen from the atmospheric air, then NOxes are also going to be created. This is the same reaction that was listed over here when we talked about the transportation sector. NOxes combined with, that's the primary pollution, combines with water in the atmosphere to make HNO3. This is the secondary pollutant here. So mostly when we talk about a particularly concentrated acid, an acid that is causing damage to trees, to crops, to soil, to freshwater ecosystems, things like that. That's mostly what we're talking about is these secondary pollutants in the atmosphere, sulfuric acid, H2SO4, and nitric acid, HNO3.